We all know that some things float in water and other things sink, but have you ever stopped to wonder why? Why do some things float while others sink? Archimedes' Principle describes this, and that's what we're going to be talking about today. I'm Mr. Wilson. Welcome to class. Before we get going, I just want to remind you, if you like nerdy content, go ahead and like, subscribe, and leave a comment. All forms of user interactions help the channel. So Archimedes' Principle states that an object will float if it weighs less than the fluid that it displaces. So to demonstrate that and explain what exactly that means, I've set up a little experiment. Here I have a bowl inside of another bowl. The inner bowl is filled to the absolute brim with water. No more water can fit in this. If I add anything else to this inner bowl, water is going to overflow and go into the outer bowl. And that's exactly what I'm going to do. I'm going to place these objects into this bowl, and it's going to displace the amount of water equal to the volume of that object. So what we're going to do is we're going to capture that displaced water in this outer bowl, and then we're going to weigh it. If the water that is displaced weighs more than the object itself, then that will tell us that the object should float. So we're going to test Archimedes' Principle by capturing the displaced water and weighing it with this scale. We're going to start with this rock. Now, you intuitively know that rocks should sink, so it will come as no surprise when we place the rock into the water. And you can see that a certain amount of the water has overflowed and ended up in the outer bowl. So what we're going to do now is very carefully, I'm actually going to siphon off some of the water so that I don't allow any extra to overfill when I pull the rock out of there. So let's siphon some off first. So again, we're just siphoning off some of the excess water here because when I pull the rock out, I don't want to accidentally have some of that water overfill and get added to our bowl. All right, I think we've siphoned off enough water that I can now grab the rock out without spilling too much more. Perfect. All right, so we're extracting this rock, and what we're going to do is we're going to weigh it to see how much the rock itself weighs. So let me clear out the scale here, and we'll put this rock right on there. So you can see the rock weighs 14.5 ounces. So what we're going to do now is weigh the water that was displaced and see how much that weighs. So our goal here now is to remove this inner bowl, and there's a certain amount of water that's been captured by the outer bowl here. So we're going to weigh the water that overflowed. Let's see if we can do this very carefully. Pull this one out. So the water that's in the outer bowl now is the water that was displaced by our rock. So what I'm going to do is put this container on the scale, and I'm going to zero out the scale so it's no longer measuring the weight of this beaker. And we're going to put the water that was captured into the beaker and see how much that weighs. So you can see that the water that was displaced by the rock only weighs 4.5 ounces. So since the rock weighs more than the water it displaced, we know that the object will sink. Let's do the same project again, but this time with an object that floats. Okay, first of all, let's go ahead and reset our experiment. So I'm going to dry out any residual water that's in our outer container. We're going to put our bowl very carefully so we don't overflow prematurely here. Put this bowl back in. And now we're going to fill this inner bowl right back up to the brim. To get ready for the next object. Again, we want to get that water level right up to the top where no more water could possibly fit. Any extra water would cause an overflow. Okay, so we're going to repeat the same experiment again, this time with an object that floats. Now you might think I'm going to go for the little ball, but actually I'm going to go for another rock. And you might say, Mr. Wilson, I thought we were going to test objects that float this time. Yes. Both of these are igneous rocks, which is a fancy way of saying they came from a volcano. But they have very different properties. And one of the properties that's interesting about this particular rock is that it floats. So let's go ahead and we're going to put the rock in the water and watch it overflow. All right, so you can clearly see that the rock is floating. Now, in order for this to work, we need to measure the entire volume of the rock. All right, so let's go ahead and push the rock completely down into the water. All right, the rock is now completely submerged, so we are now measuring the entire volume of the rock. So let's go ahead and remove it. First of all, we need to weigh the rock itself to get our baseline here. Now this rock weighs 5.3 ounces. Let's see how much its water displacement weighs. Here you can see the weight of the water that was displaced is 10.1 ounces. So what that tells us is that the water weighs more than the rock does. And so since the object weighs less than the water it displaces, according to Archimedes' principle, that means the object will float. Now the really interesting part about all of this is that Archimedes' principle applies to all fluids, and the air is a fluid too. Now that may come as a surprise to many, but the definition of a fluid is a substance that can flow. And if you've ever felt the wind, then you know that the air can absolutely flow from one place to another. So by that definition, the air is a fluid. A lot of people mistake fluids and liquids. They are, in fact, different things. Water is a fluid because it can flow from one place to another, but it's also a liquid. The air is a gas, but still a fluid. So if I immerse an object in the fluid of the air, then some things might float or sink depending on what they are. For example, a balloon filled with normal air will sink, but that same balloon filled with helium will float. And the reason why is that the weight of the air that was displaced by the helium balloon will weigh more than the balloon itself.